Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this video, we're going to take a look at how factoring a polynomial using the technique of grouping. So let's go ahead and get started here. So grouping is used when there is no greatest common factor amongst the various terms in your polynomial. Let me see if I can give you an example here. So let's see, I have the xy plus 3y plus 2x plus 6. Okay, that's not very beautiful, but you get the point. Now, as you look at this polynomial, you can see there's nothing that we can factor. I can't pull an x because not all of the individual monomials or all the individual terms have an x. I can't pull a 3 out or a y out because not all of the values have a 3 or a y. I can't pull the 2 and I can't pull the 6. There's no way to reduce this as is. And so the technique that we use in these kind of situations, because this can be factored, just not using everything at once, is a technique called grouping, where you pull out parts of the polynomial and you factor those accordingly. So let me give you the example here. If I pull this right here and make it separate, and then I pull this, and I pull this 2x plus 6 separately, I can then factor. So what I have now is I have xy plus 3y. If I factor this, well, what can I factor? I can pull the y out of it. So I put the y on the outside, and then what do I have on the inside? I have x plus 3. So this is factored now. Now, I repeat this process in a similar manner with my 2x plus 6. So I have 2x plus 6 right here. Okay, so what can I factor? I can move the 2 on the outside. And so what do I end up with? Well, I put a plus sign here, of course, and I have 2. And then I have x plus 3. Now, we're getting very, very close here. If you look closely at what we have here, we have a common factor here now, the x plus 3. Because I am multiplying the y by x plus 3, and I'm also multiplying the 2 by x plus 3. And so what am I doing with the y and the 2? Well, I'm going to add these together. And so if I want to factor this now, here's what I do. I remove the duplication of the x plus 3. I bring that down by itself because I do not need it twice. And then what do I have in my second parentheses? Well, I have my y plus 2. So there you have it. Now, just so you know that this is the correct answer, we're going to verify this by multiplying everything out. So here we go. We're going to do that real quick. So if I multiply x by y, I get xy. If I multiply x by 2, I get plus 2x because it's positive. And then if I multiply 3 by y, I get plus 3y. And if I multiply 3 by 2, I get plus 6. And you can see here clearly that this answer at the bottom, xy plus 2x plus 3y, is not in the same order, but it's the same as what we have here at the top. We have the xy here, the xy here. We have the 3y, not the same order. We have the 2x and the 2x, and we have the 6 and the 6. So we know that this system of grouping works very, very well in terms of trying to deal with a polynomial that has no greatest common factor for all the terms. Let's do one more example, and then we'll conclude this video. All right, so for our next example, we have the following. xy plus 8y plus 3x plus 24. Okay, so what am I going to do this time? Well, this is what I'm going to do. I'm going to combine my 3x and my xy. I'm going to group those, and I'm going to group my 8y and my 24. So now I have, if I were to continue working on this, I have 3x plus xy. That's going to be one set that I'm going to work with. And then I have, I guess you could say, 24 plus 8y. So what do I do now? Well, when I look at the 3x plus xy, the thing that I can factor here is the x. So if you look right here, I got the x here and the x here. I will pull this on the outside. Let me do another color here. I'll put the x on the outside. And so now inside I have 3 plus y. That's what I have. Okay, so moving on now. If I move to my next little system here, I have 24 plus 8y. Well, the easiest thing here to factor would be the 8, because the 8 is of course a factor of 8 and is also a factor of 24. So I put the 8 on the outside, and now I have 3 plus y. And now you should be able to see something here. I have a 3y here. Excuse me. Let's see if I can make this a little bit clearer for you. I have a 3y here, 3 plus y here, and I have a 3 plus y here. So we know what we do. We do 3 plus y, I guess you can say that. 3 plus y, that'll be, that'll be inside one parentheses, and then I take my x plus 8. X plus 8, like so. And again, I'll let you multiply this together, but you will get this original answer if you unfactor that, if you will. This is how it'll work. So 3 plus y, you can say y plus 3, whatever you want to call it, times x plus 8. That's our answer here for the second one. So this is the power of grouping. By taking pieces of the polynomial and seeing how you can factor those, you can do the steps separately and then combine everything at the end as appropriately. And that's the power of factoring. So, using grouping as a tool for factoring. So in this video, we took a look at how to do factoring using the technique of grouping. And so it's very simple. When you're using grouping, instead of trying to factor the entire polynomial at once, you break it into pieces that can be factored individually, and then you combine things at the end, as I've already mentioned. This is, of course, another practical tool that you can use when you cannot find a common factor for the entire polynomial. So I hope that this video was useful for you and that you were able to understand what we were talking about. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.